I'm just looking at the photomultiplier tube here. This is the photomultiplier tube without the protection aluminium tube around it. This will screw onto this insulator crystal, which is here, which passes into the vacuum chamber. Having released the vacuum on the chamber, it's quite nice to have a look inside. It's a lovely piece of kit. So we've got the Y stage here. You can see that it's turning and that's raising the table. That's the X stage. So it should be moving it along lengthways along the table. This is tilt. And then that's the Z axis, is the worm gear, I believe. X, tilt, and Z. And I just want to show the electron gun. So here is the electron gun. That sits in the vacuum, down the barrel, to the sample, insulator, photomultiplier tube. This is the whole kit for the Scanning Electron Microscope. The rest is just electronics.
There are some characters around it.
Runs a Honda S2000 as his other little car, and I think his wife's got a Fiesta or something. Oh, there we go. Oh, look, real engineering. Oh my goodness. Gosh, we're really cooking on gas now, chaps. One socket's called J71 and it's got 5 wires going to it, and that looks as though it could be scintillator supplies. No, I think it's CRT supplies. That's all good news.
So what's just happened there?
This just fell out as I...
Yeah, well, I think it's the top of the capacitor that fell off.
Oh, I'll bet.
Is this HC? It's the one we're on.
Hey,
wonderful.
Look at that.
I wondered if it might be a cap.
Yeah, little electronic.
I've never seen one like this.
Is the electrolyte dried then, is that?
It's probably depolarised and then just gone short circuit.
Yeah,
bang.
I see. Wow, well, wash your hands before you have a cookie. Pop that in the bin, I guess.
Right.
While you're testing the transistor, I'm going to fit the new capacitors. That's good? Replacing the screen, you see. And this was before we met.
Let's take that away. So we well, we'll always. I suspect its orientation is like that. Actually,
you're probably right.
And if we go
to the top,
yeah, we'll make that at the top. At the scan. I think that should have gone through that hole.
Through here.
Yeah.
You're probably right.
Once the tube's mounted up, which is fine.
Yeah.
Okay. Well,
that's much better.
Now, how do we know where it's got to be on the tube? That's an interesting issue.
Oh, it comes with a...
Have you got some scan coils on it?
Looks like it.
We should change the scan coils over because they will have been set up for this.
Yeah.
Oh, you think?
Good thinking.
Yeah. Well, that's why it's been a bit recalcitrant. Okay, right, off you come. Keep going.
You got it.
Something is stopping me.
Uh-huh.
Okay, I'm up. I'm flush.
Yep, goody. We're done.
Oh, it's so much better.
Where are the screws for this?
That'll be in the next. Put that on the table. Right. Okay. I'll take the multiplier tube.
Oh goodness, yes.
If I can stay on the... If I measure it near enough or short.
Yeah, that's good enough.
I think.
You can either take that onto there and then actually it's not enough length to get that in through the gap, so we're going to have to put it on there first.
Okay.
I think. And if we time, I know it's not lined up, but we can make enough tape there to make it a fairly substantial connection. Right. Okay.
Oh.
Hey! Right. Vacuum tube. Working distance, dynamic working distance focus. It should get to 100 You see, it says, when vacuum level reaches 8 to 100 on the emission vacuum meter, turn the vacuum valve to the 3 position. I think we're just pulling out crap from all the pipes at the moment, moisture, water, God knows what else there is in there. I mean, it might be that it might require an hour like this to clean itself up.
Well, we might have coffee then.
Yeah, time for coffee. Let it sort of fizzle away to itself. It is scanning, funny angle. Oh.
Could you just explain what just happened? Oh.
Well, we don't know why it's gone to a slow scan. It's very strange.
It's awfully bright as well. The brightness is right down.
Yeah, I have turned the brightness right down. It's too bright.
So perhaps what we've done is we've lost half of the scan that was there.
Now, where does the CRT drive coil, which you cable up, where does it actually go to? It goes onto this black wire and then comes back through where my finger.
Yeah.
It's coming through.
This set here?
Yeah.
So that goes down to this board.
I'm pulling the end of it now.
Oh, I hate to point this out, but CRT drive board, and then there's CPI, CPE, CP3.
Yeah, but it's a scan. It's not a
CRT drive,
Yeah.
CRT.
See, this is the high voltage. This will be a high voltage element to it. You see.
Yeah.
Could you show it to the camera? Do you have a clue what this does, or?
It's a scan board. Which one is it? We don't know. So these are basically the scan. This is the scan generator board.
Yeah.
Now,
These chips, are they anything we can
I
identify?
don't know what they are actually. 741.
Oh, 7-4 logic, okay.
Yeah.
So they're replaceable,
24
so we can get
Oh yeah,
new ones
they're all
there.
socketed as well. So
Lovely.
74 series logic. So that's the basic scan generator.
Yep.
This is to do with. This is a video board.
S1 there.
And photo normal rapid TV. I think these are preset brightness. Oops.
Okay.
Where do you think the bimetallic strip is then?
I'm trying to get in but I don't touch anything. Okay. That's scanning, isn't it?
Operate. So we know that's coming on because some of the bits aren't coming on anyway. It then feeds that transformer primary and it feeds that transformer primary.
But we're getting noise on the CRT, or no, we're not getting noise anymore.
Well, I think it is there. I think it's just that it's not. Adjust the brightness control so it's a comfortable level.
It's not scanning.
Not yet.
Is that it detecting something? Oh!
This is the output, right? And it goes to the end of that potentiometer, right? Power out, put the coax in.
Why are we putting the coax in?
Because otherwise we've got a high voltage floating around the end of it and it'll arc over.
Yeah, okay. Okay, so that's our culprit.
Yeah, now we've got to put the other one in.
So just on there if you can. You're right.
Yeah. So which one is it though? What's the next one?
Okay. You tell me.
Oh, the one I would be most interested in, Bernie, would be TR3. Okay. And HFE classification is an O, so it's 50 to 150. So I don't know that there's anything.
It's following the pattern of failure, isn't it?
Yeah.
I mean, those ones we replaced and the output, which wasn't giving us anything, was it?
Yeah. I've just spotted something. We've got the same transistors in the record scan, which we're not using, are we?
We've scavenged a Toshiba 2 SD110.
Do you think they're just going to be safe like that?
Do you want to cover them in electrical tape? There's some
A
tape
little
here.
bit of tape would be good, I think.
Yeah, they'll both sit on that tape. And we've replaced it into the filament power supply, is that correct?
Yep.
And that's just driving about 5 amps. That'll be driving 5 amps down the filaments at the top of the electron gun here.
Okay, we set?
Yep.
Power on?
Yep. Ho, 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 ho.
0. Ho, 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 ho. Going up? Nothing.
Oh,
Daunting, isn't it?
damn.
Nothing.
Good, that's it. That's it.
So we're recording where 2.5 amps is.
Brilliant. Brilliant. So,
It's distorted,
Hmm.
and so they use.
To me, that
lenses
looks
for-
pretty good, though. Look at that image. I mean,
Yeah, it's early to tell. I mean, we don't know what mag we're at.
and for that to be happening, the electrons are hitting it,
They are
scintillating.
indeed. And the whole chain
Scanning.
is working.
Everything's
the
working.
multiplier is
I don't know
working.
what it is that we're looking at.
It'll be some sample from my dad. You know, it will be geology, or it looks like an organic thing, right?
I can't tell. You can get metal samples that have features that look like that,
Fair enough.
but because that piece there, I don't know
Look at that.
what that
It's
is.
beautiful.
It's me focusing on that. That's more.
That's not-
That's too slow for us to do.
Yeah, the rapid 2 is the best we
I'm going to be honest with you. Normal looks lovely on the.
I mean, it doesn't
phone.
look like a bad image.
No, no.
Okay, we can't tell.
Normal scan. Oh wow, what's going on now? There's a full-sized image setting you're using. Oh wow.
So that's low mag. What I've done is I've taken that, I'm up to 80 microns, which is probably about where we need to be. But if I turn it down, you see what we're doing, we're coming through. Now, if I go up a little bit bright, I would think I need to probably tweak these around a little bit.
Yeah, it's offset slightly.
Yeah, way.
That's what. Yep. If it's under saturation, the beam will be slightly off the axis, and not coming from the point of the filament. And what Dick is doing is saturating the filament so that no further increase in current produces no further beam. That's saturation. And the phosphor retains the image. Whereas nowadays, it's all stored in digital mode. So,
whereas,
but just to
there you
to
can
set
see
it-
the difference
Yeah.
immediately.
I'm so used to seeing these.
Yeah, to set it up, you
But
need.
it's,
Whoa, what are you doing?
There's another fast mode there.
there's a dirty contact on the switch.
Something.
Okay.
Yeah.
No, anyway, I mean, I think there's a question in my own mind whether the gun is properly set up. But
Yes.
it is. And it would be nice to.
Could one of you stand there?
Why?
Because there's a reflection on the screen. Yeah. Oh, that's a. Look at that. It's beautiful, isn't it?